Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Check them out at rollbar.com/changelog. Move fast and fix things like we do here at Changelog. Catch your errors in your software before your users do. And if you're not using Rollbar yet, they want to give you $100 to donate to open source via Open Collective. And all you got to do is go to rollbar.com/changelog, sign up, integrate Rollbar into your app. And once you do that, they're going to give you $100 to donate to open source via Open Collective. Once again, rollbar.com/changelog. Welcome to JS Party, a weekly celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. Eastern, 10 a.m. Pacific at changelog.com/live. Join the community and Slack with us in real time during the show at changelog.com/community. Follow us on Twitter. We're at JSPartyFM. And now on to the show.
Hello and welcome to JS Party, where every week we are throwing a party about JavaScript and the web. I'm KBall. I'll be your host for this episode. I'm joined by the lovely Suz Hinton.
Hi, it's good to be back.
Good to have you, Suz. And we have an extra special guest with us today. We are joined by Ashi Krishnan, who is a visual poet and senior software engineer at GitHub.
Hello there.
Awesome. Ashi, thank you so much for taking the time to join us today. Why don't you tell our listeners a little bit about yourself and the kind of stuff that you're working on?
Yeah, so right now I'm at GitHub. I'm on the editor tools team. We make the editor integrations for a number of different editors. I'm going to say editors a few more times. Editors. So some other folks on my team work on the Visual Studio extension, we have a Unity extension, which I think is pretty cool. I am on the Visual Studio Code extension. So if you've used the GitHub pull requests extension for VS Code, that is partially me. And I'm also working on a talk right now that I'm pretty excited about for React Amsterdam. And I'm working on a kind of secret project at GitHub that I will say no more about. No, I'll probably say a little bit more about.
I was going to say, you're going to tease us like that? And
Yeah, we went, give us some clues or something.
I sure am doing a lot of GraphQL these days.
I haven't used it, but I heard the latest version of the API is all GraphQL.
That is true. In fact, I think we are one of the largest APIs that are in GraphQL, because whenever I go and look for GraphQL documentation or examples, 90% of them are, you can hit the GitHub API. And it's very surreal because I'm like, it's like literally exactly what I'm trying to do. So are you inside my head, tutorial writer?
I'd be interested to hear a little bit more about this concept of visual poetry that you're playing around with.
Yeah, I'm still trying to come up with a good name for it, but by that I mean I'm referring to my talks, basically, where I create talks that are stories with intense visuals and some kind of poetic component to the language, usually. I think learning from machines and living things are a couple of the best examples of this.
Nice. And I have to ask, since we're talking about sort of words and naming things, and a particular fascination of mine is the way people sort of name themselves online and how that influences the way they present themselves. So you have two different distinct usernames that I saw. On Twitter, you are, I'm not sure if I'm pronouncing this right, but Rakshesha.
Rakshesha.
And how is it?
Rakshesha, yeah.
Rakshesha. And then on GitHub, Queer Violet. Are there any stories behind those names?
There are small stories behind those. So Queer Violet is the older one. And I picked that one because I'm a strange flower, and sort of more seriously as a way to be visibly linguistically queer in a space that doesn't always make that obvious. It is, as my friend has pointed out, a little bit on the nose. And so I started to kind of lean away from it with my Twitter handle and my Instagram handle. And for those, I picked Rakshesha because the I might butcher this now. The Rakshasa are creatures. They're kind of an Indian analog of the Fae folk, where they are creatures who are other than the gods, but are like the gods in some sense. They were there before, and now they have gone away because the gods vanquished them. So a Rakshasa is sort of a female demon that lives in the lands beyond creation and sometimes comes in to do mischief.
And have you found that having those names has kind of changed the way that you present yourselves publicly?
That's a good question. I'm going to say no, but it's sort of impossible to say all of the forces that shape us into what we are. So I would like to think that by choosing that name, I've invited a little bit more trickery and a little bit more subversiveness into my online personas.
Nice. So you mentioned this briefly, and I want to bring it up. So one of the reasons we got this opportunity to have you on is because you're going to be speaking for React Amsterdam, and we're coordinating with them. We're going to have a live JS party at React Amsterdam. So for any of our listeners who are over or able to make it out to that, it should be a great conference. It's happening in April 10th through 12th in Amsterdam. And there's a really cool opportunity associated with that they asked us to highlight. And I think it's very relevant to our audience, which is they're doing these open source awards where you can submit your open source project and they'll shine a spotlight on it. And since, JS Party and Changelog, we're very open source focused, definitely take a look at that. We'll have a link in the show notes. I'll drop one in Slack now. But put your projects in so that you can get highlighted. But I kind of want to ask you, you've teased the talk a little bit, but what is it going to be? Is it one of these visual poetry talks?
It is going to be pretty visual. Whenever I'm writing a script for a talk, there's always a little bit of something like poetry in it. I try to find clever turns of phrases at a minimum. And yeah, so it's at React Amsterdam. It's going to be about WebGL and React and kind of heavy on the WebGL front. And we're going to look at, so I got an iPad, the first kind of iPad that worked with the pencil, with the first generation pencil. So I got that when it came out, or a little bit after it came out, and then it got stolen about a year later. And so I got the iPad Pro like the first day it came out, and I've just been doing a lot of like sketching and working with the stylus. And so my talk is going to kind of focus on how to take data from the stylus in a web app and render it with WebGL and do so in a React context. It's heavier on the WebGL part than the React part, to be honest, but there's going to be some React in there.
Nice.
And this is an incredibly creative talk, and I've sort of watched you produce really cool things over the last few years. I think I met you a while ago when we were both on a panel in New York, and I'm so fascinated by the fact that you have this really cool origin story of how you sort of first got, a foothold in the industry. And I'm interested in how you went from that, which to me didn't sound as creative with the coding side of things, to what you're doing actually today. Because I know that you got into code in a similar way to me with the Commodore 64 and Printline. But then what made you sort of go into the more creative side of things after you'd been in the industry for a while?
Yeah, so I've always been very interested in storytelling and in graphics and kind of putting together these interesting, creative, visual things. And I just haven't had a place to put them. Like I have, and I know it's like, oh, you could make a website and put your things on your website. And that's true. But the other part of that is I haven't had deadlines or like places where it's like, you are giving a talk on this day and you are going to stand there on stage for 30 minutes, whether you've prepared a talk or not. So you should probably prepare something. That kind of deadline is really just, my friend said, this is excellent for my creative process. And I have to agree because it forces me to actually produce things that are contained things and put them out into the world. And so I've kind of always been doing experiments and projects that I've kind of kept to myself, but giving talks really has forced me to finish things, which I think is wonderful.
Did they call it conference-driven development? I've heard people say in certain circles.
Yeah, I benefit greatly from CDD.
I have definitely done this before. I've submitted an idea and it's usually like at least 6 months out because I would never really give myself too much of a crunch. because, I might be maybe a quarter of the way into the project, but I just need a little bit of a fire lit underneath me to get it done. So I definitely relate to this.
I'll do that.
Yeah, I actually
Go ahead.
I had one of my favorite talks, Learning from Machines. I applied to Write Speak Code and I applied to Strange Loop, and Write Speak Code turned me down. And Strange Loop said yes. And so I started developing it for Strange Loop. And then Neha, who runs Write Speak Code, came back like a month or two later, and was like, hey, actually, we have a spot. Would you like to present at Write Speak Code? And I was like, oh yeah, great. That's perfect. I'm already working on it. And I agreed without looking at the schedule. And then I looked at the schedule and I'm like, I just agreed to present this in 2 weeks.
Oh no.
And so that was a bit of a crunch, but it came out, it's still one of my favorite talks. It came out really well. So I think I've started to understand why my artist friends, some of them they're almost attracted to putting themselves into a crunch mode and just like going into this hole of creativity and then coming out and being like, here, look, I've done this thing. And they're haggard and they're like bleeding, but they've done it. It feels like an accomplishment.
I feel like even if I give myself that 6-month buffer and I say, okay, I'm going to do it, and I do a lot of work and I get it 80% done, I redo it again in the last 2 weeks anyway.
Oh, man.
I do that.
I've gotten better about that.
I do that with my slides. Like the actual project is fine, but I will finish my slides and I'm very good about trying to get them done in advance so that by the time if I have to travel to get to the conference, that side of it is done. Then usually 24 hours before I freak out and I think everyone's going to hate it. And that's when I end up rewriting all of my stuff, even though I was really, really nice to myself and completed it ahead of time.
Yeah, I can never do that. By the time it's like a day or two before the conference, basically everything's locked in. It's done. I'm not making many changes. If I'm making changes, it's like put a bug in the corner or tweak the wording on these slides. By that point, the development is like code frozen, more or less.
That makes sense. And this is not the first JavaScript conference you've spoken at. You spoke at JSConf EU last year. Is that right?
Yeah, that was probably my most popular talk. And I love the JSCon. They're just very well put together.
They are. They're a lot of fun.
Mm-hmm.
So I want to dig back a little bit into Suz's question, because you talked about kind of how you got into that creative outlet, but I don't feel like we got as much about like, how did you get going into programming?
Yeah, so I have this story that I tell, and I want to lead in by saying I have kind of mixed feelings about telling it because it's very much the like started very young narrative that I think can be discouraging to people. So I'll start off by saying that like this is how I got into it, but people take many, many journeys, and there are many amazing programmers who did not do this. In my case, as Suz mentioned, my family had a Commodore 64 when I was growing up, which is, if you don't know it, it's this big boxy keyboard that has a computer inside that you plug into a television. And so my dad showed me how to write a program on it. And what that program did is it was like 10, pick a random color, 20, print, I love you, mom, 30, go to 10. And so my first program printed I love you, mom, in these random rotating colors. And I showed it to my mom and she was obviously like overwhelmed. And from there, I just kept doing it. My dad kind of stopped showing me anything, but we had these books that had programs in them. And so I'd go and like type out the whole program because you can't copy and paste from a book. And I would then, so I like typed out a program that did sort of a ball bouncing around, and then I would tweak it to make it play a sound whenever it hit the corner of the screen. And then I saw a Mac and I was like, oh, I'm going to try and do that on the Commodore 64. And I tried to make System 7 for the Commodore 64. All of these projects that like, they're incredibly quixotic. Looking at them now, I'm like, well, that was never going to work. But it doesn't matter if it works, really. Like, I wasn't trying to start a company, and that's how I learned.
Nice.
I actually, for my mom's birthday last year, I went and found a Commodore 64 emulator that ran in the browser. And I rewrote that program, which was surprisingly hard, both because I have forgotten Commodore 64 Basic and there aren't tons of tutorials on it. And also because when you're typing in that emulator, it remaps your keys to be the Commodore 64 keyboard. So I was like, where is the quote? It's above the 2, it turns out. But it was an experience of taking me back to my childhood. But I rewrote the program and sent it to her, and she was once again deeply thrilled.
I went to the Living Computer Museum recently, and that was where I saw a Commodore 64 for the first time in like, I don't know, like I'm aging myself, but obviously decades. And I forgot how different the keyboard is to a regular keyboard that we use with computers now. And I really identified with that. And it took me forever to find that quote on the 2. And also trying to remember which registers to poke to change, colors for like the border around it and everything. I was almost like sad at how difficult it was for me, given that I learned that at 9 years old and I was having trouble getting back into it.
Yeah, but when you think about it, it's like, it makes sense. It's almost shocking that we had as good a memory for all those registers and stuff at the time. Now all of that data is stored in Google, as far as I'm concerned. Like, I was teaching my dad Python, and I was like, how do you do like FFT of some buffer in NumPy? I don't remember anything. What is the syntax? Yeah.
I feel like we have this sort of fixed complexity budget of what we're able to manage. And as things have gotten easier, that means that we are doing more things, but we forget the details underlying, and we don't manage those. We copy them or use libraries or what have you.
Yeah. And it's such a, like, coding on the Commodore 64 or any of those early coding methods, they're so unbelievably painful. Like, you type you type in the whole line, you prefix it with a line number. If you get it wrong, you have to retype the whole thing. There's no like command / to comment something out. I'm not even clear how you remove a line. The emulator kept crashing in my case. Like, it's probably the worst programming experience I've had in years. And that's how I learned for like 10, 15 years. I was just like doing that. It's amazing to me, honestly. Without Google, there was no Google. How did I learn anything? I actually don't know. I couldn't tell you.
Are there any parallels between this and the WebGL work you do? And I ask this in a naive fashion because I know that WebGL is like a ton of math, but it is lower level. It is like relatively stateless and things like that. Did it sort of remind you of any of the early days of programming when you got into it, given that, JavaScript is much more highly abstracted?
I think the ways that, writing shaders a little bit, especially some of the tricks you can do when doing graphics on the Commodore 64. Like, one thing you can do is you can change the color palette. Like, the Commodore 64 has a 16 color palette that you can flip between a few options. So you can change it, and if your timing is right, you can change it in the middle of the electron beam tracing across the screen, so you can get a larger color palette.
Racing the beam.
Yeah. So there's not, direct analog of that technique, but some of the things you do in shaders where you're like, this little program is running for every pixel, they're slightly reminiscent of that. But to be honest, even that work, like when you're writing a shader program, you're writing a fairly large program in C that's going to get compiled and assembled. And even that lower level of tooling in our graphics pipeline is still so much higher level than what was available on like the C64 or arcade machines at the time.
Got it.
Awesome. Well, I think we're at a good place to take a short break. I think when we come back, I'm going to switch up our plan because we're talking about learning and stuff. And so I want to dig into, I know that Ashi has done a lot of work at boot camps and teaching and thinking about how folks learn. And since we're already talking about learning, when we come back, we'll be digging into, how are folks learning today? Where are the challenges? How are the entry points? And kind of all the pieces of how you get into the industry today. But first, a quick break.
This episode is brought to you by Raygun. With the Raygun platform, you can see a complete picture of your software health in one place. And Raygun monitors every part of your software stack in one tool. Bring your whole team and your software monitoring together, break down the walls between you, your monitoring, and your tools. Do it all in one fully integrated platform. Silently monitor every part of your application stack and highlight problems that are affecting end users and your customers. Increase software deployment efficiency, improve your code quality, spend more time building great software and less time fighting it. Learn more and get started at raygun.com/platform. Again, raygun.com/platform.
Okay, welcome back, JS Party people. Let us talk now about another topic that that Ashi has been involved with quite a bit. And I was looking at this, Ashi. It looks like you've worked at at least two different boot camp or training types of things. And I'm kind of interested to hear your perspective on. We talked about how you learned the industry, but how folks are getting into the industry now. There's been a lot of talk recently about kind of the entry points into the industry, and there's this age-old debate about fundamentals versus framework first and various other things. So maybe first just starting out about tell us what it's like working at a boot camp.
Well, it's pretty intense because everyone there, at least the boot camps I was working at, and I imagine this is fairly typical across the industry. Everyone there is making a major life change. So they've left their job, they're possibly living in a different city for a few months, and they're trying to cram a huge amount of knowledge, just facts, but also in many cases, a whole new way of thinking into their brain in 3-4 months, and then go get a job. And the whole process and thereby their entire life might collapse at any of those points. And so everyone is under a ton of stress, and you can do your absolute level best yoga, zen, stand on one leg, be the calm in the center of the storm, but you're still collecting all of that energy, and you're still being buffeted around. There's still, every single cohort, there's a student crying in the bathroom, or many students crying in the bathroom at various different times. And so it's an intense experience. It's also, and partially for that reason, very rewarding. So you get to see people go through that process and then actually have their lives changed. For the most part, it does work out. Students do get jobs. They are, in my experience, typically happy with them, but my experience is obviously slanted towards the students I've kept up with more, which will tend to be the students I connect with more, which will tend to be people kind of like me. And so I can't be said to hold a representative sample. But in my experience, it is very rewarding and very intense. And also a little bit, after you've been there for a while, it's a little bit like Groundhog Day, because you're teaching the same material every 4 months or every 3 months even. And so you get to know, it's I didn't know Rails or Ruby when I started at Dev Bootcamp, which is a Ruby on Rails shop. And I learned it during the course of being there. And then now I would say I know it pretty well. And then similarly, I didn't know Angular when I started at Full Stack, and I didn't know React when we started teaching React. And now I definitely know both of those, or I know React a lot better than Angular. And so you keep getting better at the technologies, and the students necessarily don't.
Right.
Which is fine and understandable, but that for me started to get a little bit frustrating, feeling that tension where I'm oh, we can do this wild thing with contexts and hooks and this and that. And students are you need to slow down. We learned for loops a month ago.
Right.
Yeah.
How does it compare to, let's say you're working on a product team and you're mentoring a junior who's just been hired? Are there differences in your approach? I mean, I know that this is a strict curriculum, but I know that when you mentor juniors at a company, you tend to be goal setting with them and things like that too. Are there any similarities, or is it very, very different?
There's definitely a lot of similarities. Right now, when I'm working with or mentoring more junior devs, I find myself doing a lot of similar things. We will goal set, we will pair together, we will just the way we'll go through things, and the way that I'll find myself slipping into an explanatory mode. I should maybe check it. Maybe this is just annoying for all of my colleagues, but I think there are definitely similarities. There's also some notable differences where, because the time frame of a bootcamp is so short, there are some aspects of software engineering that you can't delve into that deeply. So testing, for example, we encourage it, or we would encourage it as instructors, but it's really hard to see the benefits of it when the longest project you're ever going to be working on is a week and a half. That's just long enough to encounter your first, oh, we broke everything and we don't know when we broke everything, and everything is falling to pieces. But it's actually almost not worth writing tests for a project that's only going to live that long. And so those kinds of engineering practices are a little bit harder to teach, I think, in the context of a shorter bootcamp program.
That makes a lot of sense.
Absolutely. So what would you say having seen this at a couple different boot camps, teaching kind of different-ish curriculum, but looks like both pretty web focused. What would you say are sort of the hardest things for folks coming into the industry right now to get their heads around?
Promises.
I love that you said this. Yes.
At that level, it's definitely promises. I think async await will probably help this a little bit. We weren't using a very async await heavy curriculum when I left full stack. I think that'll make it easier to manage, at least, because obviously if you change something to being asynchronous, you don't have to refactor everything that calls into it. I think it'll create this different problem, though, where people don't really understand the distinction between what is synchronous and what is asynchronous, which honestly, people's grasp on what is synchronous and asynchronous is fairly loose to begin with, and then won't understand some of the subtle timing things that come up, where in an async function, you can no longer trust the JavaScript bedrock of no other JavaScript will run between these two lines.
Right. Interesting.
And eventually promises have to come back into it as well, because that's sort of, it's syntactic sugar on top of that.
Yeah, of course. And you will sometimes end up using promises directly. Like you'll see some async function returning, I don't know why you would do this, but returning promise.resolve or calling an async function and then chaining .catch onto it is a favorite of mine that sometimes throws people for a loop.
Mm-hmm. Yeah. Yeah, I wonder how much of the challenge is just asynchronicity is hard, regardless of how we sugar it up.
Yeah, there is definitely some of that. I also feel like there's a sense in which the world would be simpler to reason about if everything were asynchronous. On the other hand, if everything were asynchronous, you're basically back into we've got multiple threads going and I don't know when I can trust anything anymore land, which I think there are models that we are slowly discovering that will make handling all of this stuff easier. I actually think React kind of offers something like a glimpse at how we can handle asynchronous resource management in some future language. I'm being vague.
That's okay.
Intentionally.
Well, yeah, I mean, it is interesting because increasingly we're seeing frameworks pick up more and more of the things that we might have previously had to manage ourselves. And so some of that may be asynchronicity.
Yeah, and just my comment about React, I was kind of alluding to how you have this materialized component hierarchy. You've basically acquired all these resources and you have almost like an Erlang service, but lines of communication are structured differently. You have all these like little services, each of which represents an asynchronous resource, and data kind of flows through them at the pace that each of them are able to accept. And so each little microservice, it's not even a microservice, each little component is managing its own state and managing its own invariants. And then the framework is structuring how data flows between all of them. And so I think and how, in particular, how to set up and tear down those services as we need them or we stop needing them. I think we're going to start to see that model replicated in different spaces and towards different ends.
That kind of leads into a question that I had. A common criticism of boot camps is that they end up teaching all about some framework and students come out not understanding any of the fundamentals. And there are arguments back and forth on that, but I'm kind of curious both what approach the boot camps you worked at took and what your take is on kind of how to design curriculum for folks trying to get into the industry after a 3-month boot camp.
How to design curriculum, like post-bootcamp grad curriculum?
Well, kind of the extent to which boot camps can or should be focused on fundamentals. And if not, how does that feed into sort of what should you be doing post-bootcamp?
Yeah, so at the 2 bootcamps I was at had slightly different approaches to this. So I think Dev Bootcamp's curriculum, I did not personally like it quite as much. And it didn't really have many CS fundamentals. I think there was a workshop on something. I think there was there was a workshop where you made a Boggle, an AI that could look at a Boggle board and find all the words on it. And I think there was a chess AI project that nobody ever finished. And then at Full Stack, they, to my knowledge, still have a few workshops. The first ones actually are on CS fundamentals. So they have you write a linked list and a hash map and probably some binary trees and maybe a trie and some algorithms that like common traversal algorithms. And those, it's interesting because I'm still undecided about how useful those workshops were. I think it's good for people to have gotten that exposure. And most students, I think, felt like it was probably good to have that exposure, but then they also felt like it wasn't very connected to the rest of the curriculum. And it's pretty hard to fault them on that because the frameworks we use work at such a high level that you very rarely have to, find a cycle in a graph yourself. Mm-hmm. I did that the other day, but it's not the most common problem that you have to solve. Most of these problems have been solved. And I personally learned from, I guess, what you would call a frameworks first approach, right? The framework was C64 basic, but nobody sat me down and taught like 6-year-old Ashi, here's a linked list, here's what memory is like, here's what it means to peek or poke a register, like nothing, none of that. So I learned how things work by poking them, and then through that developed mental models that turned out to be mostly correct for both how things worked and then how to structure programs. Like I remember in college, I wrote some code and the instructor was like, "Oh yeah, you're using the like composite pattern here." And I'm like, that's what I'm doing. That sounds great. It's a good name.
That is definitely something that we can relate to a lot when you're sort of using a whole bunch of words to describe something, and somebody who obviously knows the terminology is like, "Yeah, that's just a queue," and you're like, "Oh, okay." I'm sure that happens in boot camps as well, given that it's so hard to link what you just learned to, well, what is React made up of? How do you map like a graph of DOM nodes to like the graph that you learned about, like in a very abstract form, like a couple of weeks before?
Yeah, exactly. It can be, and I think it can just be very challenging for students to make those connections, especially while they're in the boot camp when everything is still very liquid. Like nothing, I think, fully congeals until after they can cool down a little bit, the stress is a little bit off, and they can sort of are able to like relearn everything they learned, but in like a more solid way. I think like this is their first exposure to all of these concepts, and so everything kind of is like murky and vaguely connected. And I actually think the students who do best are the ones who kind of are able to look at something and be like, okay, I kind of get that. Moving on.
That makes a lot of sense.
Which honestly is something we do a lot in coding, right? Oh yeah, I kind of understand what's going on here.
I have to get this feature out the door, so I need to move on for now, but maybe I'll come back to that later, sort of thing.
Yeah.
We're progressively refining our mental models here. So that kind of raises the question of what types of jobs does a boot camp legitimately prepare someone for? Like, are they ready for any entry-level job? Should they be looking particularly at companies that have well-established internal training types of programs? Or like where, are you at the same level of readiness you would be coming out of a CS degree? Like, where does this land you?
This is a really fudging answer, but it depends so much on the student. Like, there are students coming out of boot camps who I think are far better prepared than CS grads. We actually had CS grads come to Full Stack and go through the program because they were like, I went through the CS program and didn't learn how to program. Like, not enough to... And some of this, I think, is confidence and what they feel like they know versus maybe what they actually know. But they were like, yeah, we just didn't write much code. I don't feel like I can go and get a programming job right now. And so the bootcamp is really great for that, obviously, because they have the fundamentals and they then like get a lot of practice in actually like building apps. But then there's also students who come in with like no experience and I think would do great and would like probably do better than many graduates from 4-year programs who didn't have like a very practical programming component, or maybe graduates from 4-year programs who just weren't that connected with it or didn't like haven't like yet figured out how to engage the material in a way that really lights up their brain. So I think, yeah, I've had students who go on to do like pretty standard web dev engineering with the stack that we taught, and so Node.js and React and all that. And I have students who go into working on at a hardware startup on like C code. And both of those students are, to my knowledge, doing great.
Awesome. Well, I think this is another good time for a break. So let's take a short break. And then when we come back, we're going to dig into developer tools, which is your most recent job, and thinking about kind of what needs to be done there. Where are we as an industry in terms of tooling, and maybe looking particularly at tooling within the React ecosystem, since we have been talking a lot about React. But we'll be back shortly.
This episode is brought to you by Gauge. Gauge is a free and open source test automation tool by ThoughtWorks. The goal of the tool is to take the pain out of test automation, and to help with this, Gauge supports specifications of Markdown, which are easy to read and easy to write, reusable specifications to simplify your code, which makes refactoring easier, and less code means less time maintaining code. And finally, integrations. Use Gauge with your favorite tools and your IDEs in the ecosystem of your choice. Selenium, Sci Pro, CI/CD and CD tools like GoCD, Jenkins, Travis, and IDE support for Visual Studio, VS Code, IntelliJ, and more. Head to gauge.org/JSParty to learn more and give it a try. Again, gauge.org/JSParty.
Okay, welcome back, and let us talk about developer tools. So Ashi, your new position, you said, is focused on developer tooling. Is that something that you've been working on in other places as well, or this is something that's a brand new area for you?
It is, well, it sounds incredibly geeky to call it a passion of mine, but it is a passion of mine. As I think with all programmers to some extent, we work in these tools, in these highly specialized tools so much, we inevitably develop opinions about them, and we want things from them. And yeah, so I have opinions about developer tools.
Do tell.
Oh, what are they? I think they're incredible, and they should be better. They can be better, I'll say. The hardest problem in debugging something, at least, is it's always like seeing how the wiring runs through the different layers. And it's always something that can be improved, right? To have, I want to say it is getting better. Like right now in VS Code, you can like run a program, attach a debugger, and see really within your editor, see everything that's happening in terms of the data flow within it. But I think even that can be improved. We can see more integration between the layers, more ability to cross-cut, sort of cut into our application and see a cross-section of like, okay, here's where the input event comes, and then here's everything it triggers, or here is how this variable is changing over time, and here's like a histogram of the values it takes on, and all these kinds of things. And then, of course, in the WebGL side of things, like when you get into those slightly deeper layers, the tooling is not the greatest. Frequently, you will write a shader and you will run the program and you will see nothing whatsoever. And there's like no error on screen. There's just nothing. Mm-hmm. And that's the worst. That is absolutely the worst.
Yeah, absolutely.
What do you think are some low-hanging fruit for developer tools that are sort of more general, that you see time and time again when you're using a developer tool? Like, what are the sort of things that can be addressed that some people just sort of have a blind spot to if they're developing a tool for other developers?
Oh, that's an interesting question. I wonder if I know of any low-hanging fruit. I definitely can see some really delicious fruits up near the top of the tree.
I love that.
We can talk about that, and then we'll just like all salivate thinking about them, and it'll pretend they're low hanging.
Yeah, let's do that.
Yeah, well, I'll say that any time that you can make transparent some aspect of the program, that is a great opportunity. So I love how in VS Code's debugger mode you can just kind of mouse over and see the values of everything. I almost wish there was a little bit more like there was a sidebar or something that showed me for each line, here's the values that each variable is taking on in this line always. And so I could just like, without having to inspect each one manually, I could just go and see this list of changes. I also think anytime you can create extension opportunities. So anytime you can offer an API sounds so big. What I really want is the ability to write a little bit of code that talks to the program in a meta way. So if I can write a GraphQL query to query mutations that have happened to a particular variable, say, that would be nice. Or if I can write a little bit of JavaScript. Okay, sidebar. I've been working in TypeScript a whole lot recently, and I think it's really cool. I think it's really great. There are numerous times when I just wish I could tell TypeScript that the type of this variable should be generated by this JavaScript function that runs in the compiler. And there's no way to do that. I can kind of understand how that breaks all kinds of mathematical, this algebraic, whatever form is impure if I'm allowed to write JavaScript that goes and computes what the return type should be. But I should be able to write JavaScript that goes and computes what the return type of a function should be, given not the runtime values of the type, but the input types that it was called with. And so I think that kind of meta-ness, where you can write code that describes how this code should be assembled, that is something we're starting to get into. And I think it's actually going to be very powerful. I recently, for one of my talks, wrote just this little preprocessor that takes a YAML file and parses the keys in a particular way. And if the keys have a special form, it goes and generates a file with a file extension as specified in the YAML. And it creates this like JavaScript file that goes and imports all of those, and kind of the YAML tells you how to wire them up. And working in that has been surprisingly enjoyable. You sacrifice some things, like you don't get syntax highlighting for the embedded fragments, but I can put like pieces of 5 different languages together and describe how they should build, all from one file, which feels very nice. It feels very contained, and it feels very powerful. Like I can see how if I had a little bit of a programming language rather than YAML surrounding this, I would have something where I could do a lot with very little effort by building on top of this huge ecosystem we have.
Interesting.
Do you think there's a bit of death by config going on right now in the industry?
I think there has been. I actually feel like we're in a fairly good place right now. I mean, I feel like I'm in a fairly good place. I think different projects are in different places, but as someone who's working on some pretty greenfield development at GitHub and who often does greenfield development for talks, I actually feel like I can create a project and parcel that, and it just works these days. And if I want it to work differently, I can write a plugin that honestly probably does some things that the parcel folks would find terrifying. But it's my computer.
That is one of the things I was wondering as you're describing, configuring your build with YAML and then wanting to apply some code. Like, is this kind of the target that Parcel and Webpack and those folks are aiming at?
I think, yeah. So the project I was describing just then actually ran on top of Parcel or ran under Parcel. All that tool did was generate a bunch of files, which I then parceled up, or was parceling up constantly. And so, yeah, I think those tools that give us kind of the ability to glue together all these different languages, and JavaScript is kind of the lingua franca of all of them. So your CSS gets compiled into JavaScript, your JavaScript gets compiled into JavaScript, your TypeScript gets compiled into JavaScript. That is creating this very powerful ecosystem that we're just starting to understand the edges of. Like, we're just starting to get into how powerful it is to be able to build all of these languages together. And I think that WebAssembly is just going to open up another huge, huge avenue for putting the power of that, the power of the web.
I do wonder a little bit how we walk that balance between simplicity of use for the vast majority of cases while still empowering those who really want to mass configure everything. Because metaprogramming is one of those places where it's like you've got plenty of rope to hang yourself, and we kind of if we push everybody to like, you're going to configure all of your build, you're going to configure your code in code and write self-generating code, like we end up in a place where like debugging and analysis gets really hard.
Yeah, and this is where I think it's important to be able to trace a piece of data through all of the layers and understand how all of the different layers of, or at least have something that understands how all of the different layers of compilation worked and get you back to some source file. And ideally be able to explain the problem that you're seeing at the end in terms that you as someone who wrote the input could understand. And we're definitely not there yet. A huge amount of times I like load a module and I think this still happens. Actually, Node doesn't like load source maps for the first tick or something. And so I get this error in a generated file somewhere that nobody has ever heard of. And this is definitely a place where I think we could improve a lot, being able to like maintain that linkage while adding more and more layers to the stack. Which, as someone who's tried to write Babel transforms and Webpack loaders and that kind of thing, it's not super easy to maintain that linkage as you're doing everything. You have to write your parsers and write your tooling in a way that understands that what you're doing is cutting up pieces of another thing that itself might be generated in order to generate something else and maintain those connections through that whole process.
For sure. Let's talk a little bit about the React ecosystem in particular, since our excuse for talking today is React Amsterdam, and it sounds like you've been doing a bunch of stuff in React, both on the teaching side and then in the development side. Where do you feel like the holes are in terms of React tooling, or where are the really cool opportunities that are getting started?
There's a lot of cool stuff out there. Right? There's in terms of plopping a component down on a page and feeding it data and seeing what happens. Do I think React tooling is just great? I feel like there needs to be better tooling around hooks, since hooks are now going to be the new hotness for the next year or so.
Mm-hmm.
Right now, if you go into the React developer tools and you look at a hookified component, it's just like the internal state. You get to see how they've implemented hooks, which is cool and all, but not really that useful to me. If you look at I guess the props are normal. Yeah, so that could improve, and I'm sure will improve. Outside of that, I have complaints about the framework in certain respects. Like you can get in. I've definitely gotten into these states where a component will crash within an error boundary, and it'll like crash loop within the boundary because the boundary keeps restarting it. It would be nice if there was some kind of globally introspective, global way to capture failures like that, to see the tree and be like, oh, this component is in an error state. And ideally, like, here's why it's in an error state. Oh, I think the props didn't match. Oh, I'd be able to get sort of a more readable error message than like prop types help with this a little bit, but sometimes it's not strictly speaking a type issue. Oh, on that note, something the whole world could benefit from is if TypeScript had a shape of operator. There's no reason on God's green earth why the compiler can't see like shape of X and be like, okay, whatever I think the shape of X is, I'm going to replace that expression with that JSON. And that would enable all kinds of things. That would enable you to auto-generate prop types from the typings for a thing. That would enable you to auto-generate GraphQL from the typings of a thing. There's a number of times when I've wanted to sort of just get at runtime the type information for a variable. And I know that there's like a way to do this by turning on experimental decorators and doing some reflect thing, but it seems like there are holes in that. Like that doesn't work with free-floating functions and a few other cases. And it would just be nice if I could just ask the compiler to tell me what it knows.
Mm-hmm.
Tell me what you know. Sing like Michael Cohen.
But then would we be able to trust it?
I want to ask you actually about how you feel about integration testing in React right now. Like, how do you feel about where it's at and where it needs to improve?
I don't know. I haven't done much integration testing in React, which I think is probably a sign that it could improve. I'm actually having trouble even thinking about what it would look like. Like, I guess you have a whole app and you want to go through some flows of it. Is that sort of...
Yeah, that's definitely it. I think that I really like where we've gone with doing snapshot testing and things like that, but that tends to just be very much like the state contained within one component only. Whereas like obviously none of these components are sitting in a vacuum in that way.
Yeah, so being able to look at the whole, sort of how the whole page is working. Yeah. I actually wonder, is that something that we should do at the React level or still the DOM level?
I think that the snapshot testing that's come out of this, to me, has been one of the big sort of unsung heroes of not necessarily React, but just like, given that we're doing more and more single page applications and the JavaScript on the front end is responsible for more, we had to sort of create more sophisticated tools. And so I'm hoping to see some innovation in the integration testing as well, just partially because, you know, when you're on a website and it's a single page app, and sometimes you have this funky UX experience and you can feel the actual programming, or you can feel the declarative pathway that led you down there, and it's just quite jarring, and it's almost unfortunate that you know exactly why it happened. Like I'm wondering whether there's any innovation in trying to sort of address those things that happen.
I think if I were working on integration testing for the web, I feel like I would have one layer that is like really DOM and assistive technologies focused. So it would, like, you would express how to do something either by like recording a series of clicks and having that get mapped to, oh, okay, she clicked on the button with this name and the like control with this label and the link with this label and so on. And then maybe on top of that, having some layer that will connect those DOM elements, again, like cross-cutting through layers, that will connect those DOM elements to the component that rendered them, and be able to let you address the components address the DOM nodes via the components, but then also will track down like, okay, this component didn't match its expectation on this page. But I sort of feel like for integration testing, and I don't do a ton of like production web front end work these days, so I'm actually not that familiar with the current web page state of the art. But I feel like for integration testing a web page, I want to do something at a deeper level than React, like not quite pixels probably, but probably at the like assistive technology layer of like, here's all the things that I think do something on this page, and here's how I think they should behave. And then maybe actually have some testing at the pixel layer too.
I think those two levels definitely make sense.
Yeah, I like you talked about dev tools providing transparency. I think having a way to implement testing at each of those levels and kind of transparently drilling down through and just sort of addressing the tests at different levels of abstraction would be super valuable. We've seen tremendous progress in JavaScript unit testing and things like that, but I think, Suz, you're onto something. Like, integration testing is still very hard. And it may be there are tools out there that folks have used really well, but they're not as well marketed and discussed, or the tooling may just not exist.
Yeah, I think it's hard because when you start talking about integration testing web pages, you quickly get towards like, oh, well, I guess we better spin up Chromium and spin up a renderer. And once you're spinning up Chromium, you better test it in multiple renderers. And then you're in Selenium land, where sort of you have all of these different browsers installed and you've got them in VMs, and it's all pretty hard. It's actually, there must be cloud providers that do this, right? But I can see how it would be hard even to configure those. There's probably space here for some cloud provider to come in and be like, we will just do this. Like, we will give you a Chrome extension that records you going through test cases in your app, and we will like track what your app does, and you can tell us what you're expecting, and we will just like create all these test cases and then run them on every platform you said you cared about.
Yeah, I think Browser Stack does something like that, but I haven't used it.
Yeah, that sounds right.
I'm not 100% sure how it works. I've only used Browser Stack for manual testing. I haven't used their more recent automated stuff, but cool. So yeah, I think we've highlighted some why dev tools are really interesting. And a lot of really other interesting stuff. Any last thoughts on dev tools before we wrap up the show?
I have none, I think. No, I have ideas and I have projects, and you'll be hearing more about them over the next year and a half.
Exciting.
We have exciting things.
Awesome.
In our futures.
Excellent. So everybody follow Ashi on Twitter, Rakshesha, or we'll include a link in the show notes.
Please do.
And we will listen for those. And speaking of following her, once again, remind you, she will be speaking at React Amsterdam coming up in April, 10th to 12th. Sounds like they have a few tickets left. So if you hear this and you want to jump on that and go see if you can still get in, that would be great. But even if you're not, take a look at their open source awards. If you have a project that you're working on, they'll shout it out and get it more visibility. So definitely take a look at that. Ashi, thank you so much for joining us today. Been wonderful having you on.
Thank you so much for having me.
All right. And that is it for this week's JS Party. Take care, y'all. Have a great week and join us next week for a party about JavaScript.
All right, thank you for tuning in to JS Party this week. Tune in live on Thursdays at 1 p.m. U.S. Eastern at changelog.com/live. Join the community and Slack with us in real time during the shows. Head to changelog.com/community. And do us a favor, share this show with a friend, rate us on Apple Podcast, go into Overcast and favorite it. And thank you to Fastly, our bandwidth partner. Head to fastly.com to learn more. And we move fast and fix things around here at Changelog because of Rollbar. Check them out at rollbar.com. We're hosted on Linode Cloud servers. Head to linode.com/changelog. Check them out and support this show. Our music is produced by Breakmaster Cylinder. And you can find more shows just like this at changelog.com. Thanks for tuning in. We'll see you next week. Practical AI is a show hosted by Daniel Whitenack and Chris Benson about making artificial intelligence practical, productive, and accessible to everyone. You'll hear from AI influencers and practitioners, and they'll keep you up to date with the latest news and resources so you can cut through all the hype.
As you were at the Thanksgiving table with your friends and family, were you talking about the fear of AI?
Well, I wasn't at the Thanksgiving table because my wife has forbidden me from doing so. It's off limits for me, lest I drive her insane because I never stop.
New episodes premiere every Monday. Find this show at changelog.com/practicalai or wherever you listen to podcasts.